You want to run Stable Diffusion locally, but there's a problem. Your computer's garbage. It's a dinosaur. It's an ancient, mystical beast. So what can you do? You could try running on the CPU, but then you would become a dinosaur, an ancient relic by the time that the first image generated. So no, you need a better solution. And luckily, we have that solution now. It's called XFormers. What XFormers does is it allows you to run Stable Diffusion more efficiently. So that means you can run it on a smaller GPU, or if you have a super high-tech fancy GPU, it'll let you run it faster. Bit of something for everyone, but especially something for all the boomers out there. So, this video is especially dedicated to you. You may be the reason that I'll never afford a house, but you also did invent Wi-Fi. Okay, so first off, I'm gonna come clean here. I'm basically just plagiarizing this article. All the information that I'm giving to you pretty much just comes from this one article. So read the article. It's really good. Mathieu Tolemont. Good man. Okay, so we're gonna get a little bit technical. So put your technical hat on, okay? And just do a bit of a concentrate for the next minute. There is a mathematical operation called attention, which is used in a lot of modern machine learning techniques. I'll link you to a video that explains attention a bit better. The point is, this one attention formula is computed thousands and thousands and thousands and thousands of times every time you run a single Stable Diffusion inference iteration. It's also used in other places too, but it's like a really common function. What XFormers does is it makes this operation much cheaper, basically. Okay, so how does XFormers improve the attention operation? Well, it has to do with the different components on your computer and how they interact. So on the one hand, we have the processor. And what the processor does is it actually performs mathematical operations. So let's say we had to perform a very basic mathematical operation. We wanted to find out what the value of B was. And we didn't have the time to do it ourselves, so we're asking our computer to do it. What happens deep inside the sort of workings of the computer is that the processor performs the actual math, and the random access memory stores things like results. So in this case, what the processor would do is it would perform this computation, right? This 4 plus 8. That will be done by the processor. And then the value of A would then get stored somewhere in the random access memory. Okay, and then at that point, this computation is complete and the computer will move on to the next line. It says B equals A minus 1. So then what has to happen is the computer has to go find the value of A from inside random access memory. It'll perform this computation, A minus 1, on the processor. And then again, once that's finished, it'll store the value of B somewhere in random access memory. Okay, and then the computation is complete. Okay, so that's sort of how the processor and the random access memory work together. The processor does the math, and then it stores intermediate results in the random access memory, the RAM. Now, really important distinction to make here, okay? The random access memory is not the hard drive memory. When you boot up your computer, you have all these files and folders and text documents and so forth. All of that information is stored on the hard drive, which is like really slow, permanent storage. The random access memory is for information that's being used right now and never needs to be kept in the future. When you boot up your computer, your hard disk has a lot of things on it, but your random access memory starts off empty. And as your computer runs processes, it puts things into the random access memory. And as soon as you turn the power off, everything in the random access memory gets erased, kind of. So random access memory is like really fast temporary storage. Hard drive memory is like slow permanent storage. Hard drive memory, not important to XFormers. You can completely ignore it. All we're interested in is these two components. And I guess one sort of interesting thing is that both of these components exist on a GPU. Usually, you'll have two sets of RAM and two processors in your computer. One will be the CPU, a processor with its own random access memory, and one will be a GPU, or maybe you have multiple GPUs. And each GPU will have a processor and some random access memory to work with inside that GPU. When we were talking about things moving around and being saved before, this is a process that's occurring entirely inside of your GPU. Or it could be occurring entirely on your CPU, if that's where the code's running. Okay, so those are the components we're working with. And now let's talk about how the attention mechanism is computed in terms of those components. So the attention mechanism starts off with three matrices that are stored in the RAM, and then a bunch of operations get performed on those matrices to get an output. Remember, this is the attention mechanism that gets called, thousands and thousands and thousands of times every time you want to do an inference with Stable Diffusion. And roughly speaking, what the actual mathematics is that you perform a matrix multiplication between the Q and K matrices. You then perform a softmax on that outcome, and then finally you multiply that outcome with the V matrix. Don't worry too much about what that actually means mathematically. We're just going to step through the processes right now. So first, we take the Q and the K matrices, and we pass them over to the processor, we load them in, and we perform this matrix multiplication. As a result, we go ahead and we store that in this new sort of intermediary, this M1 matrix. Okay, so far we've performed 2 read operations and 1 write operation to the RAM. Next, we load the M1 matrix back into the processor and then perform this softmax operation on that M1 matrix. We also perform a bunch of other different operations as well, but for now we'll just think about the softmax. Once we have the outcome of that softmax operation, we then store the result into the random access memory again, and this is called the attention matrix. The output of this softmax operation is known as the attention matrix, and usually it's pretty big, it's pretty huge and chunky, and it takes up a fair bit of RAM. Okay, next we load the attention matrix back onto the CPU, and together we also load the V matrix onto the GPU. Remember, we started with these 3 components, Q, K, and V, and we do another matrix multiply, and then we go ahead and save that finally back onto the RAM, and we get our output. That's it. That's the attention mechanism finished. That's the computation. It's done, and that output will then be used in something else to make the neural network function. Okay, so throughout this whole process, we have 5 reads, 3 writes, and we have this one big chunky matrix that gets stored on the random access memory. So that's the kind of efficiency that we're looking at to begin with. Okay, so enter some smart people who worked out a cool way of taking all of these operations and kind of just schlonking them into a single operation. If you want more detail on this, read the article. Again, it's like really, really good. But essentially, rather than having all these different things, multiply, softmax, multiply, and a bunch more things inside the softmax, they just created one single function. And that function takes all the 3 matrices in, and it just spits out the output in one go. So that's what? That's like 3 reads, 1, 2, 3, and then all 3 matrices on the processor. And after that, you have this one single write to the output. 3 reads, 1 write, and then you avoid this big intermediate attention matrix altogether. In the article, he talks about how what they actually do is they break up the matrices and perform small bits of the computation in chunks. So rather than reading in all these 3 at once, they read in a tiny bit of Q, a tiny bit of K, a tiny bit of V, and then spit out a tiny bit of output, and then iterate on that until you get the final result. And in fact, they end up iterating in parallel. But the point is, it's much more efficient. And of course, this new way of doing things is called XFormers, or it was also called flash attention in one of the papers. And there are sort of a few different ways of actually implementing it, but the implementation that we're going to use is XFormers. Okay, so that's all well and good. In theory, this should be faster, but how much faster is it actually in practice? Well, according to the benchmarking that the guy in the article did, or that he found or whatever, yes, it's much, much faster. And I've had people in the Discord saying that they got, half the memory, twice the speed type situations. So it looks like it's definitely worth doing. What I'm going to do now is try to actually implement it myself, and I'll show you what improvements I end up getting. All I'm going to do is just install XFormers in my current Stable Diffusion Webui. So all you need to do is follow along with me, and hopefully you should be able to achieve the same results. Okay, so now let's actually put it on our computer and see how we go. But before we start that process, what we want to do is work out how much of an improvement we're going to experience. So I'm just going to do a test. I'm going to do a before test where we're just going to see how fast our computer is at the moment with Stable Diffusion. So without running anything, we're using, what does it look like? 3.6 gigabytes of RAM on our GPU. just sitting there, just running the Webui by itself. So now we're going to start generating an image. Let's generate like 2 images. And if we run nvidia.smi again, see that our usage has gone up to 5 gigabytes. We can also increase the batch size to 2. That means we'll be generating 2 images at once. And we'll still keep the batch count at 2, generate nvidia.smi while it's generating. And now we're using almost our entire memory card at the moment. We're doing a whole 7 gigabytes. And just to be thorough here, because I want to make sure that we've got a good sample, I'm going to generate 10 batches at a batch size of 2, and we're going to use the stopwatch app to see how long that takes. Okay, so generate. Okay, so that took 1 minute 19, which is like 79 seconds. So 20 images, oh gosh. 20 images divided by 79 equals, okay, so it's about 4 images a second. That's what we're looking at. Okay, cool. So that's the before, and now what we're going to do is we're going to install XFormers and try it again and see if there's any improvement at all. We're going to go from scratch here. I'm assuming that you have nothing installed on your computer. You've just pulled it out of the garage, and we're going to start going. So we're going to go through a whole bunch of things right now. Okay, so the first thing we're going to have to do is install the Webui that we're going to use to run the Stable Diffusion. So I happen to have it here already. This Webui here is the only one that actually allows us to run XFormers at this point. So this is the one you're going to have to use. If you have another one, I'm terribly sorry. It's just not going to work. So we're going to go to code, and we're going to go download zip. Excellent. We have this Stable Diffusion Webui. We're going to extract it. Really important now. We have to extract this into local disk C, because if you extract it anywhere else, later on the line, we're going to have issues with the path being too long. Possibly you could just extract it to somewhere else, similarly short pathed, but I would recommend just doing this, because otherwise the chances that something goes wrong is going to make everything really, really annoying. Okay, and then just extract. It's a fast process, it's very nice. And so now if we look at local disk C, we have Stable Diffusion Webui. Because I'm someone who doesn't like taking chances, I'm going to rename this to Webui, just to make sure that all the paths are really short. We don't want that long path issue to come and bite us. Trust me, that's going to be a huge pain in the neck. Okay, so Webui, we click in here, and the next thing we have to do is we have to take a model file and put it in there, because at the moment this is just some code, and what we wanted to do is run Stable Diffusion. So we have to grab a copy of Stable Diffusion and chuck it in there and put it in the right place so the code knows where to find it. I happen to have one already, but if you don't have one, the repository shows you where to find it. Just go to the installation and running section, then there's this nice dependencies link you can click on, go to the dependencies, and there are a few different options for downloading the model. I'm just gonna, the official download is I'm sure it's good enough. Now, this is through Hugging Face, so you might have to make a Hugging Face account and then accept the license or something with Hugging Face, but it's pretty straightforward. You just need to follow their steps. I happen to have the model already, so that's great. It's under this nice SD models file. It's just called model.ckpt. Yours might be called something different, and if it is, make sure that you rename it before going any further. So rename it to model.ckpt, copy it or cut it, or whatever, go back to local disk, go to Webui, and then just paste it in the top level directory. Nice. And then, at this point, we're sort of ready to go. The only thing we need is Python version 3.10. And it's really important that we use 3.10. No other version will work. I guess to clarify, the other versions will let the Webui work, that's fine, but only Python 3.10 works with XFormers. So just trust me on this. You will have to install a new version of Python. Luckily, that's not too difficult. So first we just check that we don't have Python 3.10 already. So cmd. Where Python, this just shows us where all the Python executables are in our computer. And as we can see, we have a few versions of Python, 3.7, 3.6, 3.9. We don't have Python 3.10, so we're going to have to get it. Then we go download Python. Great, Python 3.10, it's right there. I've also included a link in the description because I'm a helpful guy. And okay, there are a bunch of different options. We need to check which kind of version of Windows we have. So Windows, system information. There's this line here, system type. And if it says x64 based, which yours probably will, then that means that you need to get this x64 installer. If it says x32, then you'll need the 32 installer. I always get the installer because it's an executable file, which means we can just click on it, run through the wizard, and we don't have to worry about anything else. Very quick, very nice. Important thing, tick this box, otherwise your computer won't know where to find Python and it'll be a whole annoying scenario. So just tick that, install now. It's very fast. Okay, sick. So now CMD again, where Python, okay, great. Now you can see that there's now a Python 3.10. And just to be 100% certain, we're gonna go Python version. Okay, and so it's probably quite important you do this because this shows us that the default Python your computer is going to go to is going to be 3.10. It won't go to all the others. And that's important because later we'll be running Python commands and we want to make sure that the Python commands automatically go to 3.10. Okay, so next what we want to do is install CUDA. And it's very important that we install CUDA 11.3 because other versions of CUDA, basically, they just won't work with XFormers. XFormers is very particular because it's like some sort of new technology. So Windows is our operating system. We already know that we're a 64. Version 10 is fine. I guess I can only assume that these are for like servers as opposed to just regular computers like what we have. And we always want the exe. Exe local sounds more like what we want. So we'll just go ahead and download that. And again, of course, as always, it's going to take a long time, so we'll have to wait for that. Okay, so that took about 20 minutes to download, and now we just double-click this, and if the heavens are willing, and if the gods are smiling upon us today, then we'll be able to install CUDA. Yep, this seems like a fine destination, that's okay. Okay, so we're pretty safe to accept this licensing agreement from NVIDIA. They're fairly reliable. Express is fine. Yep, that's fine. Okay, easy peasy. We don't want to launch samples. That's just like to show off how cool the graphics card is. Okay, so now in theory, CUDA should be working. And if we open the command prompt, like a new command prompt, not the old one. Yeah, in NVIDIA-SMI, that means that NVIDIA is like installed and working, and we can actually see what's going on our GPU. 2 for 2, that was actually pretty easy. And before we move on, I'm just gonna go ahead and launch the Webui to make sure that it's working properly and nothing strange is happening. So back into CMD, go to local disk C, go to Webui, and then there's a few ways that you can launch this particular Webui. The way that I've found is best, especially when we start using XFormers, is through the Python launch.py. So that's what we're going to use. You'll see there's this file in here called launch.py using the dir command up here, dir. It shows you what files are there, launch.py. So now we're just gonna run that. So we go Python launch.py. And this is going to launch the Webui. You can see that it tells us which Python it's using, 3.10. Wonderful, wonderful, wonderful. And we just have to wait a bit, and then we can actually just confirm that everything's working. It's really important that we do confirm this and that we just use the Webui normally before installing XFormers, just so that we know if anything goes wrong later, that it's an XFormers thing and not something to do with the Webui itself. Having that certainty is so important. I can't stress that enough. You always want to check and test everything as you go when installing things like this. The first time that we start this Webui, it's going to install a whole bunch of different things. It's going to download them from the internet, so it'll take a little bit of time. So just like sit tight for a bit. It might take about 10 minutes. Okay, so we've actually hit an error of some kind. We launched the Webui and then something weird happened and we've gotten this strange error. Index error, list index out of range. I don't know what this is about and I'm not familiar with this code base. So the first thing I'm going to try to do is just run the code again. Maybe it'll work this time. Okay, same issue. So that definitely didn't work. It looks like maybe we're missing an upscaler or something. So now I'm going to look at the install and see if there's like a step that I missed. Okay, so what actually ended up happening was I found this issue on GitHub, which was created 1 hour ago, talking about the exact issue that I was having. Right, this exact line of code, which should look pretty familiar to you. As I was reading it, it was like 6 minutes ago, fixed with git pull. So that means that some sort of error occurred in the repository when I downloaded it, and immediately they found the error and they fixed it. So all we have to do is just download the code again, and then of course move the model back into the checkpoint. So I'll do that, and then when I've done that, I'll come back and we'll start the tutorial again. See Webui models, and just chuck it in there. And again, super important, model.checkpoint. Okay, so that's everything we need to do. Check the Python version again, just to be safe. And again, this will mean we have to install a bunch of dependencies, which is fun. God damn, that took a long time. It launched though, we're fine. And so now we just go to this URL, Control copy. Okay, so there we have our apple, all good stuff. So the next thing we have to do is install Microsoft Visual Studio, which is, to be honest, I don't even know what it is, but it's required for the XFormers thing. So if for whatever reason you're watching this video and you've decided you don't want to do any XFormers stuff, you can actually just stop right here. We've come as far as we need to, and you can just go ahead and use this Webui. But XFormers, you need Visual Studio. The link to this website is in the description. I just hit the first download button and it'll create an exe for you. And great, we've got our exe. So we just double click that sucker. Continue, wait a tiny bit. Okay, now importantly, you need the 2022 community version. Other versions don't work with XFormers because again, XFormers is a bit temperamental. And we just need desktop development with C++, which is all of these packages here. Make sure that it says install while downloading or else it'll take ages. And even so it'll take ages. So be prepared to wait about an hour or so for this to actually install. Okay, so that actually finished a lot quicker than I thought it would. Microsoft is gonna ask you to sign into a thing and you're gonna close that down. You're gonna get rid of that completely. Now comes the tricky bit. This is the actual hard bit. We're gonna go to that guide. This is the part where we actually have to install XFormers. So the first step here is to do this venv activate thing. Now, I'm gonna try to get away with being a bit sneaky here and not doing the venv thing and just using the default Python on my machine, which importantly is Python 3.10. Okay, it's all working. Now we can continue down this process. So we go to the repositories directory, then we do this command, git clone XFormers, blah, blah, blah. I'm assuming that you have git installed already. There's a small chance that you don't, but if you don't, just go to this Git for Windows link and you can just download this here, follow the wizard, and it'll be easy to install. Okay, that was mercilessly quick. So now if we go dir, we see there's this new XFormers directory, which we go into. Excellent. And now we run this command. Okay, again, another pretty quick process. So now what we've done is we've grabbed all the XFormers code and it's sitting on our computer. The next thing we have to do is work out which compatibility version our GPU is. Okay, so this guide suggests you visit this link. I find it easier just to start Task Manager. And then go to Performance, and then GPU, and then you'll see, here we go, NVIDIA RTX 350. So apparently that's what my GPU is. Notice I have two GPUs here. If you have one that's like Intel, just ignore it. The actual GPU is this one. So I'll just Google that. 350 Ti. It says laptop GPU, but we can ignore that. And then you find the NVIDIA page that actually tells you about that laptop. There are a bunch of other pages that will talk about that GPU. Ignore them. And just find the place where it says stats. There should be some place just saying like stats in big letters. Yeah, okay. View full specs. And the thing we're looking for is CUDA compatibility version 8.6. Great. Now we know what the CUDA compatibility is. We can go back here, and what does it tell us to do? It says, okay, set torch arch list equals, and then 8.6 for us. Okay, done. And basically, we're about to build XFormers locally on our computer, and XFormers has to know what our CUDA compatibility version is, or else it won't be able to build properly. So that's just something we have to do. Okay, so now pip install requirements.txt. This is just installing Python packages. And this will be installing all the Python packages required for the XFormers repository. Before we do that though, we're just gonna play it safe here and install the CUDA version of Torch Vision, because if you just install the requirements, sometimes you'll get the CPU version of Torch Vision, which will run on a CPU, which we don't want. So Torch Vision is one of the requirements. We're just going to install the CUDA version of it explicitly. It looks like it's already installed anyway, so for us that was no problem, but it's good to do that first. Okay, so now that's all good. Pip install requirements is the next step. This might take a while, it depends. For me, it was instant because I have already installed all the requirements, apparently. And now, this is the tricky step. Pip install e dot. And this actually builds XFormers here locally in our computer. Last time I tried to do this, I had so much trouble. You have no idea how much I was just pulling my hair out over this step. So, we're just gonna run it. And as we can see here, it's failed. It's failed horribly. But this is actually an error that you can expect. So it says unsupported Microsoft Visual Studio version. So we have CUDA 11.3. And we're using a version of Microsoft Studio that expects a higher version of CUDA. So for some reason, that's not a problem. And all we have to do is explicitly tell the computer that to ignore that. So here we go. Before actually doing that installation, we put this argument in. We say set nvcc flags equals allow unsupported compiler. And that will prevent this unsupported version error from occurring. Pip install e. We'll try that again. Now you might think, oh, isn't it just easier to install CUDA 11.8 or something? I don't know, but what I do know is that CUDA 11.3 and Microsoft Studio 2022 work if you put this flag in. I have no idea what happens if you try CUDA 11.8. God knows what demons or mysterious creatures will haunt and hunt you if you try to do that. So I just like to play it safe. Okay, so I've got some good news because it's been running the setup and it's been running for about 3 minutes now, and I haven't seen any errors or crashes or anything, which probably means that it's all gonna be good. So I'm expecting it to be another 20 minutes. I'll log back on when that's happened. Okay, See this? See this here? Successfully installed XFormers? This is good. This is good. This saga that I embarked on many years ago is drawing to a close. Now we need to edit some code. So we need to take this, force enable XFormers, copy. I have VS Code installed at the moment, so I'm going to use VS Code to do that. And I'd recommend installing VS Code. It makes things very easy. You don't need it necessarily. You can just use any kind of text editor, just like Notepad or something. So I'm going to find the launch.py file. Right. So what I've done here is I'm inside the XFormers directory still. We need to be inside the main directory. So we're going to go up 2 levels. Start VS Code again. Then we're going to say we trust the authors, because we do. Launch.py. Okay, and then here it's going to, we'll search for command. What did the guide tell us? Command line args. Okay, so we're going to search for that. Okay, command line args. At the moment it's empty, so we're just going to add this in here. Command line args force enable XFormers, and the file we're editing is just launch.py. It's in the root of the directory. Okay, close this now. And in theory, this should work now. We should be able to use XFormers. So, Python launch.py, exactly what we did before. The only difference now is that it'll have this argument force enable XFormers, and with a little bit of luck, it'll actually use the XFormers correctly. Go back to the Stable Diffusion UI, and we'll just generate. Moment of truth. Oh, I have to stop recording. I have to stop recording or else it's not going to do anything. Okay, and basically it works really well. So I'm using a computer here with around 4 gigabytes of RAM. Yeah, just a tiny bit over 4 gigabytes of RAM. And I'm able to run Stable Diffusion with a batch size of 3. So I can generate 3 images at a time. So that's pretty damn cool. That means basically, as long as you have an NVIDIA GPU, you can run Stable Diffusion. Okay, cool. Now I understand this process was probably the most tricky installation process I've gone through with you guys. There was a lot of kind of twists and turns here. If you need any technical support, I will be monitoring the YouTube comments, and there is also a Discord that you can join where there are some clever people who can probably help you out. Okay, and then final benchmarking. It took us 53 seconds with XFormers to generate 20 images. That's using like the larger batch size. Okay, so that's about 3 seconds an image. Okay, and so after all that, what do we get? We get a 1.5 speed increase, which if you're only doing this every now and then, probably not worth going through that whole saga that we went through together. But if you're on a daily basis generating art, this is a big deal. This is a very big deal. So yeah, hopefully you can do something with that.